Okay, everybody, let's have a quick look at this question here. It says, at what points on the curve y equals x squared over 2x plus 5 is the tangent line horizontal? Okay, so what we're going to do here is we're going to take the derivative. Now, there are a couple of different ways we can take the derivative of this particular function here. But the most recent rule that I've gone over with my class has been the quotient rule. So that's what we're going to use. We're going to do the quotient rule here. So the derivative is going to start off with, it's going to be, remember, it's the if, actually, I'll start it like this. Just to quickly review the quotient rule here, if y is equal to f divided by g, then y primed is going to be the derivative of f multiplied by g, okay, minus f multiplied by the derivative of g, all over g squared. So now in this particular case here, y primed is going to be then the derivative of the numerator, 2x, multiplied by 2x plus 5, the denominator, minus the numerator, x squared, multiplied by the derivative of the denominator, which in this case is just going to be, sorry, you should see that up there, 2. All over 2x plus 5 squared. Okay, now we just got to simplify that a little bit, and I'm going to do that by expanding the numerator here. What I'm looking for here is anything that I might be able to cancel. Okay, so 2x times 2x, we get 4x squared. 2x multiplied by 5 will be 10x. And then I get minus 2x squared all over 2x plus 5 squared. Keep going here. My derivative is going to be, okay, so 4x squared minus 2x squared, I'll get 2x squared plus 10x over 2x plus 5, all squared. Now it would be wonderful if I could simplify this and cancel something with the denominator. Let's have a quick look. What can I factor out of the numerator? Well, I can take out a common 2x, and that's going to leave me with x plus 5. Ooh, shoot. Not quite the same as the denominator, but that's okay. That's okay. I didn't need it to cancel out here. It just would have been nice if it did. So now I want to find out at what points along that curve, okay, is the tangent line horizontal. Now let's just think about that for a moment. If I've got a line that's horizontal, what I know about that is the slope. And in fact, that's why I jumped onto the derivative right away here. Okay? Because as soon as I say that the tangent line is horizontal, I've given you some information here about the slope. So that's what I'm going to use. So now what I'm going to do is I'm going to set this derivative here equal to 0. Okay? So y primed will equal 0, and I'm going to let that equal 2x, x plus 5 over 2x plus 5 squared. Now, notice that I can't let the denominator go to 0. So there's this restriction here. I'm just going to put this off to the side here. I know that x cannot equal, and if I look at the denominator and think about that, if 2x plus 5 is equal to 0, bring over the 5, which is negative 5 divided by 2. I can't let x equal negative 5 halves. That's not going to work. Okay? So as long as the answer that I find here isn't that, I'm okay. Now, the denominator is not going to be responsible for making this expression equal to 0, so I can multiply through by the denominator. Okay, multiply both sides through by the denominator here, and that's going to go away. But really, you could almost think of that as more of a logic step. The denominator is not responsible for making that equal to 0. And now I've already factored this. Well, the only way this is going to go to 0 is if, well, 2 isn't the problem. 2 is not making this equal to 0, but that x could. It could be that when x is 0, the whole thing goes to 0. Or it could be when x is equal to negative 5. So I've got these two scenarios here that are going to create a horizontal tangent, okay, or a line that's got a slope of 0, or tangent line that's got a slope of 0, I should say. And neither one of those is equal to my restriction, so that's good. So now I just need to figure out what the points are. So I've got 0 here, and I've got negative 5. So now let's go up to our function, because remember, we go up to the function to get the point. If I plug 0 into that, okay, well, if I plug 0 into that, because of that numerator, this is just going to go to 0. So the origin is a spot where this occurs. Now I take negative 5 and plug it up here. Well, negative 5 squared is going to be 25. Negative 5 times 2 is going to be negative 10. Plus 5 will be negative 5. 25 divided by negative 5 is going to be negative 5. And so I'm going to get negative 5 down here. And so those are the 2 points where that the tangent line of the graph is going to be horizontal.